Hello, welcome to lesson 9.3.3. How can I use ratios? Applying ratios. So I guess today is about ratios. Um, you've done a bunch of ratio work this school year, and this is one of the closing opportunities for you to show me that you can do this. The setting for this is going to be something called estimating fish. Fish biologists need to keep track of fish populations in the waters they monitor. They want to know, for example, how many striped bass there are in San Francisco Bay. This number changes throughout the year as fish move in and out of the bay to spawn. Therefore, biologists need a way to gather current data quickly and inexpensively. Today, you and your team will model how scientists might make an estimate of the number of fish in a body of water using an application of ratios. And we move this under the sea. Get it? No. Estimate fish populations team challenge. Your team will be given a lake with fish. Do you think you can find out how many fish are in the lake? Determine the number of fish in your lake as accurately as possible without actually counting the fish. Then count the fish to determine the accuracy of your results. So yes, you are going to figure out, you're going to use proportions to estimate it, and I'm going to teach you how to do that. And then at the end, you'll count how many fish are actually in the lake, and then you'll see how close you were. You can read these discussion points. If you can pause your video, read through them, and take a moment with your team to actually discuss the points. What are you supposed to find? How do you think fish biologists determine the population of a lake? Kind of talk those through for a little bit, and then start your video again and move on from there. So, problem 109. Since it is impossible to count every animal, biologists use a process called tag and recapture to help them estimate the size of a population. Tag and recapture involves collecting a sample of animals, tagging them, and releasing them back into the wild. Later, biologists collect a new sample of animals and count the number first time captures and recaptures in the sample. First time captures are you catch them, but they don't have tags, and recaptures are the ones that are still tagged. Then they use the data to determine the population size. Your team's task is to use the tag and recapture process to estimate the number of fish in the lake. Now you might notice they keep talking about beans and paper bags and things like that. So if we were in a classroom doing this, because obviously if you're watching this video, you're working from home, probably distance learning. So if we were in a classroom, I would have a paper bag filled with a bunch of beans in it, and your job would be to take some of those beans out, mark them with a marker, put the beans back in, let them swim around, and then you would take a new sample out. Now, if you know how many tagged beans are in the bag, when you take your next sample, it might have some tagged beans in it and some untagged beans. If you use a proportion of tagged beans to total, and you compare that to the tagged beans in the lake to the total lake, you can figure out how many fish are in the total lake using a proportion. Well, we're not going to use beans. We're going to actually use a simulation. And your job is going to be to answer A through I. There's a question I, goes all the way to I, by following the instructions with your team. Now, what the rest of this video is me showing you how to use this tool. The tool is kind of cool. Wiki, wiki. So I'm going to open that up, and I'm going to get rid of my video here and show you how to use this. So this is a tool I found from probably a university somewhere, and it's an estimating fish tool. Now, if you look at this, there's a whole bunch of buttons going on here. We have to set our parameters over here on the side in green, and then click the setup button. So when it's your turn to do this, you guys will be doing this with a different setup. And then over here, some buttons for marking the fish, unmarking the fish, so that's tagging them, and releasing them. This, the net, this is how you're going to catch the fish. Down here at the very bottom, this is where you're going to keep track of the total number of marked fish. And then this bucket, the sample bucket, is going to be how many are marked in the bucket and how many are total in the bucket. And then how many are in the total current sample. So for an example, I'm going to do for you let's do a medium pond with a medium population and we'll do a large net, medium, sure, let's use a large net. I don't know what's going to happen, we'll see. So you pick the data and then you hit setup and then you hit go and the fish start swimming around. Let them swim just for a little bit. Let them mix them up really good. And then you're going to click on the dip net, click, boom. And when you do that, it catches some of these fish and puts them in this bucket. Now, it's hard to count how many fish there are. And I was supposed to take an estimate, by the way. I estimate, I'm going to restart this here really quickly. I'm going to release them. If I had to estimate how many fish that is, I'm going to say it's about 1, 2, 3, 4, 5, 6, 7. Oh, you can't count them. I'm going to estimate 80. I'm going to dip that net in. And now down here at the bottom, it says that I caught 21 of them, but none of them are marked. And in the lake, there were none of them marked yet. So it's time to mark the fish. So I'm going to mark all 21 of them. I'm just going to click that 21 times until everybody is marked. Now what I'm going to do is I'm going to take that set of 21 and I'm going to release them back in the water and let them swim with the other fish. Let them get nice and mixed up. Let them swim, 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 swim. So now I know that there are 21 fish in this lake that all have marks. So when it comes time for you to fill out some of the papers on this experiment, the resource page, I would say right here, I estimated there were 80 fish in the lake. I think I said 80. The total number of fish in the first sample that we tagged was 21. We put them back in the lake. In the second sample, the second time I scooped some up, that's what we're going to do next. So let's scoop up the fish. So I'm going to go here and I'm going to dip into the lake. And it says that in this bucket, there are 20 in the bucket and 3 of them have marks. I can see the 3 pretty easily. So what we're going to do is go back to our paper here. In the second sample, there were a total, what did it say, of 20 and 3 were marked. There were a total of 20 in the net and there were 3 that were tagged. Part E, you're going to create and solve a proportion using the numbers from A. Oh, that's a mistake. We got to use from B and D. Oh, I got to fix that. And we're going to use that to help us set up a proportion. So, tagged total sample lake. This row is going to represent the tagged. This is going to represent the total in the sample in the lake. Remember when we did the percent problems, we used a number line to help us set up the proportion? We're going to do the same thing here. And the thing we don't know is we don't know the total number of fish in the lake. So I'm calling that one X. That's what we're trying to find. We do know that in the lake, there are 21 that are tagged. We also know in the sample that there are 3 tagged and 20 total. 3, 20, 21. We're going to use this to set up a proportion. 3 is to 20 as 21 is to X. Now, I can actually do this one with a giant 1. I can see that if I multiply this by 7 and this by 7, then I get 7 times 20 is X because of the equal sign. So I can say X equals 140 fish. I know that there are 140 fish in the lake. At least that's what it looks like. Now, if you don't like that method, you could also have said 3 over 20 equals 21 over X, and we could cross multiply, and we would get 3X is equal to 420. When you divide by 3, x equals 140. Same thing, different method. This was the giant 1 method, right? So we did the experiment once. My first time I did the experiment, I got 140 fish. Now, part F, release the fish back into the lake, let them swim a bit, and do the experiment all over again. All right, so I'll go back to my lake. This is my favorite part. When you release them in the lake, then they start mixing back in. Mixy, mixy, mixy. Let them mix, let them swimmy, 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 and then dip into the lake. This time, there were 18 in the bucket and 5 are tagged. So when I go back to do my math, let's see, I'll do the math here. There should be enough room on the paper for you to do at the bottom when you see the real paper. But if we have 0, this is my total, this is my tag, and here's, I don't know how many total. I do know that there are still 21 in the lake. Remember this number, that's not going to change. But in this sample, what did I have again? 3 and 18? We had 5 and 18. 5 tagged, 18 in the bucket. So I have 5 tags, tag row, 18 in the bucket. So 5 is to 18 as 21 is to x. Cross multiply. 5x is equal to, what is 21 times 18? 8, 16, 0, 1, 2, 8, 7, 378. Probably should check that math. Divide by 5 to get my giant 1. X is going to be equal to 7, remainder 28, 5, 75 and 3/5. That's about 76 fish. Round it to the nearest whole fish. So in this case, X is about 76 fish. Now, wait a second. That's not very close. Those two numbers are really far away. It might be the average of them, maybe right in the middle. Or I can go up here and do part G. Part G is going to give me permission to do the experiment again, but it's going to tell you, by the way, that every time you do the experiment, it costs you $500. So we're already $1,000 in, but my two numbers are too far apart. I think we should do it again. So if I go back and I release the fish and I let them swim, 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 and then catch them. This time 6 out of 25. So I got another, this next one here. If we're going 6 out of 25, I'm going to do it here. So we had 6 out of 25 compared to 21 out of x. This is 0, 0. This was tag. This was total. Sample. Lake. So I could say 6 is to 25 as 21 is to x. 6 is to 25. Cross multiply. 6x equals 21 times 25. Let's see, 5, 2, 0, 10, 5, 525. 6x equals 525. Divide by 6. X equals 8. Remainder 45, 7, and 3, 6. So about 88. About 88 fish. So let's see. The first time I did it, I got 140. The next time I did it, I got 76, I think it was. Is that what our number was? 76. And now I just got 88. Let's take the average of that. 14, carry the 1. Say 12, 20, carry the 2, 304. What is 304 divided by 3? That's about 101 and 1/3. So I would, about 101 fish. Once you have your estimate and you fill in your paper, so I'm estimating that there are 101 fish. We did the experiment 3 times. It cost me $1,500. Now we get to go and figure out what is the actual number. So we got to go catch all the fish. So I'm going to dip in, and I'm going to keep dipping in until I catch them all or I can count them all. Turns out they don't disappear till they cross the middle, so you can kind of wait till they're there and start tapping when they get to the middle. I think they dip the net into the middle all the time. You'd think that those fish would get smarter. Oh, I got one more. Come on, there we got him. Okay, so it looks like I have 100. See down here at the bottom? So with this process, there were actually 100. Compare that to 101. Check mark, happy face. We did a great job. Your job is to go do this with the tool. Go do the experiment 2 or 3 times. Fill in this paper. When you finish the paper, take photographs of it, upload it to Google Classroom. Here are your parameters. I want you to go back into the link. Oh, watch this. We get to release them. Release the fish. Oh, I love that. Okay, so I'm going to stop them. I want you to do this problem, but this time, instead of a medium pond, I want you to change it to a, let's go medium pond, large population, and large net. Medium, large, large. So when you go to do this, medium, large, large, and you click setup, you get this picture. There's your estimate, medium, large, large. So you are going to do the following. Sorry. Come on, wake up. There we go. Okay, do the experiment. With a medium pond, a large population, and a large net. A large, I think they said net, right? There is what you're doing. Have a great time. Call me if you need help. Thanks for following along with me.